Okay. Let's see. So in Australia, they had a really big trouble. They had a really big problem with rabbits. So they had, at a time, they estimated there were 1 billion rabbits in Australia. Guess how many rabbits that started with? Anybody? So a rancher in the early 20th century, late 19th century, 1800, 50, 60, brought 10 rabbits to Australia to farm them, because you can consume rabbits, actually. It's seen as like a lesser, but you can eat rabbit, yeah. At least that's what my grandpa said, who grew up during the Depression. He said that rabbit's actually really good. So you don't have to eat it, okay. But the 1 billion rabbits came from a small group, a really small group. Because, has anybody ever heard that? You reproduce like rabbits. What does that mean? A lot, right? Because they can have a litter in just a number of weeks, maybe months. So if we have 2 rabbits here, how many rabbit offspring do they have, do you think? Just take a guess. 8? Does anybody actually know? Anybody have a pet rabbit?
I don't have a pet rabbit, but I'm guessing like over 10 per litter.
10 per litter? Is that a good number? We go 10? Who thinks it's over 10? How about under 10? Okay, that's 4 people. Thanks for the 4 people that voted. We're going to go with 10. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. That's only in the first, 2 months. You know, they reproduce. There's new rabbit litter. Now, those same 2 rabbits are going to keep producing, every couple months. But what's going to happen to each of these rabbits? They're going to reproduce what? It's even too much to put. So if we have 10 for each of the 10, we end up with how many? 100 after the first 2 generations here. So we've gone from 2 rabbits to 100 rabbits in the number of months. What's going to happen to those 100 rabbits now? Assume there's a mate for each and it's not just incestual. So what's going to happen each? The 100? 10 for each of those, right? So the next generation, there's going to be 1,000. Now, we started at 2. We ended up at 1,000 after 3 generations, right? So you see, you can get to 1 billion. There's attrition. Some rabbits die, some get old, all this. Rabbits don't live that long. So it's not going to just be that, none of the rabbits die in this process, or, here's the deal. If I was doing 1 new rabbit every single year, I would have 0 to start. I'd have 1 after the first year, 2 after the second year, and we'd end up with what kind of equation? What kind of equation do we have here? Linear. It would be linear if it was 1 unit of 1 unit of time, 1 unit of quantity. Kind of like the rise over run. It would be consistent, right? Same. But what kind of function are we dealing with when we have this kind of growth? When it's way faster than this. It's not 1 per year, it's 10,000 per year. So we start off with 1, or 0, or 2. We start off with 2, and we go really steep. It starts to increase. This is exponential, because the growth rate, the rate increases so fast, it's no longer linear. After a couple months, then suddenly you're at 1,000, then you're at 10,000, then you're at 100,000, really quick. So we're dealing with these kind of equations right now. Exponential. We're going to do a little bit of calculator work, because the main part of today's task is calculator work. We'll get to that. It's not so big deal. Not that big deal. So this is growth, exponential growth, talking about bunnies. How about exponential decay? What's something that you think decays exponentially? I'll give you a hint. Maybe you can figure out what I'm talking about. So if this happens, the sea level would increase by 10 feet. The sea level would increase by 10 feet. What's the one thing people are talking about? Global warming is causing what to melt? Ice. Where's the biggest? Well, where's one of the biggest ice kind of Safe havens, yes.
Antarctica.
Antarctica has a huge amount of ice. It is in the south. It's being affected slightly less, but there are some ice shelves coming off. You guys know about Greenland, right? Greenland? Okay. Greenland has so many glaciers that if Greenland melted, all that ice melted, it would raise the sea level by 10 plus feet. Now, that would change. That would be trouble, right? Miami's gone. Santa Monica, most of LA would be beachfront properties in the water, right? So it's not just linear. It's not like we're losing 1,000 pounds of ice every month, right? Because what happens is the ice starts to melt. It pools on the top, right? And since the water is warmer than ice, it starts to melt it from the top. The sun will bounce off, and the water ends up being a little darker than the white ice, so it absorbs more heat. The water trickles down under the glacier and starts melting from that side, causing it to like flow faster. So that's why this is actually really important for your guys' generation and your kids, because, I mean, if you live beachfront property, that could change in the next 100 years. And you say 100 years, that's nothing. But that means your grandkids are living in a really, really hard time. Okay, so it's something that we have to deal with right now. It's not something that's just like this theoretical, right? If by 2021 or 2100, at the end of this century, it's 10 degrees hotter, none of you guys can go out in the summer. If it's 125 degrees here, we're in trouble. Okay, so a lot of this and a lot of the discussion around glaciers and ice and climate change is kind of a misunderstanding of this as well, because things aren't linear. It's not like it's getting worse at the same pace. It's getting worse much faster, and that's why your generation, I have a lot of faith in you guys. I think you're going to figure it out. You guys will figure it out. Or at least you'll care about it, not just pass it on. Because your grandkids are going to have to deal with it. Don't you care about that? Eventually you'll care. Once you have a grandkid, you would care, right? You would care. Okay. So exponential growth, bunnies growing. Exponential decay could be glaciers melting. Here's the deal. We always start with both of them with an initial amount. Okay, an initial amount of ice, an initial amount of bunnies. If we're doing growth, what's the difference between the growth and decay? What's one thing you see that's different? This one has addition, this one has subtraction. So it's 1 plus some kind of rate as a decimal, raised to the exponent, which is time. Okay, so it's not so bad. It's not so bad. We're going to practice finding and dealing with this rate, because I think we got to first remember what is the rate as a decimal form. So first before we start to play with these, I want to start down here just to remember. Convert between percentage and decimal. So I want everyone to try to do that for 50% really quick. I'll give you 5 seconds. 10 seconds. 50% is what? Check with your neighbor. Make sure that you're on the same page. What did you do? Maybe give that hint. How did you find it? Good. 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 Okay. All right. Jude, what did you and your partner come up with? 0.5. 0.5. And who has a hard time when you have to go between percentage, decimal, and fraction? Who doesn't, who doesn't have a hard time with that? Often we have a hard time remembering basic stuff like this. No big deal. So use 50% as your guide. 50%. Cent. Like cents. It's 100. Percent. 50% is how much money? 50% of a dollar is 50 cents. Now, how much is 50 cents as far as a dollar? Is it a third, a half, 2/3, quarter? What do you think? It's half. So when you're on the SAT, you forget, how do I do the decimal to percent to fractions? How do I convert between those three, right? Your example is, think about 50%. 50% of a dollar, 0.5. 0.5 of a dollar, 1/2. You see how that's going to help you? 50% is the magic number that we can all remember these rules from. What was the rule? Jude, how did you find, if you had to describe it, how did you move? Well, it involves a decimal. What did you do?
You would move the decimal to the left.
How many? Twice. So we're here. We're going to end up with 0.34. The fraction part I gave you was just for when you get to the SAT, so you don't have to keep doing the fraction part. But I want you to do it for 2.5 and 200. Go ahead and put that into a decimal form. Let's see if we can all arrive at the same bits. Check with your neighbor if you're just like, nah, blank star.
Yeah.
Good. I see it. Okay, let's go with Antonio. Help me out with this one. 2.5% is
0.025.
2.5. We moved it 2 to the left. Boom, boom. Anytime you have space, you got to add that 0 to have a placeholder. 200%. What's that? This one's the one that's kind of tricky. You're like, can it just be a decimal of that? Yeah.
It's like 2.
It's just 2. 2.0 if it helps you think about it, but we're just moving it no matter where. Here's the decimal point 1, 2. 2.0. Okay. Thumbs up, sideways, down for doing this process. Good. This is just a basic component. So what we've just figured out, we're going to be given a percent. Now we know how to put the percent as a decimal form right here into the equation. Okay. So you got this step. You got to look at the problem and find your initial. And then we're going to go ahead and figure out this time and all that. Okay. So one thing to remember here, I'll put a star. If the growth rate, or I'll say it is a growth rate, if this value right here is greater than 1, it's a decay rate if this value, this multiplier here, is less than 1. Okay, so that's how we're going to just be able to know and see really quickly if it's growing or it's becoming smaller. But looking at that, we have to now be able to combine that information. We have the rate at 25%. What's the growth rate? I know it's growth, so I'm just looking right here. The growth rate is this entire expression here. So go ahead and first convert the rate into a decimal, plug it in, and give me the growth rate. That's all we have to compute. And then from there on out, we do a little bit of calculated work. Okay. So first, you're going to change this into a decimal. Because it's a growth rate, we are going to apply it to our growth formula and put it right in there. Simplify. You're going to get an actual value. See where it's going? Loretta, what is 25% as a decimal?
0.025.
Good. 0.025. So it's 25%. Here's the decimal. 2 to the left puts it at?
Oh, wait. It's 0.25.
Yeah. I thought you were saying this, but actually,
That's what I meant.
that's what you meant? I thought that. So here's 25% right here. To find the growth rate, what do I need to combine this with? Right there, right? Okay. So we're just going to go the 1 plus the 0.25. You have $1, you add a quarter, what do you have? 125. And look, we know it's a growth rate because it is defined as a growth rate if it's greater than 1. Sometimes this value is called a multiplier. A multiplier can be growth rate or decay rate. You see how it's just like a word that categorizes both and contains both of them. But specifically, we would say growth rate or decay rate. Okay. Thumbs up, sideways down for doing these 2 steps so far. Okay, we've gotten pretty far into these formulas. So we are going to try to do this first problem. So I hope you have some space. Get out your calculator right now, actually. Get out that calculator. We will have a quiz on Friday, and you will not be able to use your phone. So I have 5 today. You can use your phone if you don't get one, but Friday is none. Did you need one? Katie? Imitation is the greatest form of flattery.
So thank you.
No, you should say you're welcome. Okay, these problems look like they should be trickier than they are. Really just kind of, it's not like what we did with the word problems last week. It's actually more straightforward. It's more plug and chug. You use the formula, the correct formula. So I'm going to look here and read it for us. In 2016, the population of a town is 35,000 with an annual rate of increase of 2.4%. First off, first question, is this a growth or a decay problem? Growth. What's the word? Increase. Clues, right? Decreases, reduces, that's going to be decay. Increases, growth, that's going to be growth. So we know it's growth. So we're going to use this formula eventually. Let's go ahead and now find the growth rate, which remember, we have to change it into a decimal. Change into a decimal. Triangle means change. You'll learn that in chemistry. So change into a decimal. We know that rate. We got to first find the growth rate by converting that. It's what we did down here. So let's go ahead and do that step now. And I'm calling someone randomly, so let's make sure. If you're a little behind, you're not sure what we're doing right, ask your partner. Maybe they can clue it in for you. Okay. All right, Alejandro, help me out. Let's see. Let's go ahead and put this as a decimal. What's the decimal of this?
0.024.
Perfect. If I'm finding the growth rate, I'm using the growth equation over here, so it's go ahead and fill it in the rest. What's next?
1 plus 0.024.
Which equals?
1.0.
Yeah. Good. Everyone else get that too? Got that? Hypothetically. Let's put in as much information as we can. Let's write the equation. We're going to be copying this down one step at a time. Y is equal to. What is my initial amount? 35,000. 35,000. I'm multiplying that by our growth rate, which we already converted the rate into a decimal, added 1. We got 1.024. Now we have to put an exponent right here. I want you to tell your neighbor what exponent is going to go right here. We have a unit of time. We have some unit of time. And actually, I think this right here, this helps us. Look here. Look at the start, the finish. How much time was that? Okay. Marcus, what do you think? What's that? Not sure? You want to ask Jackie or someone else in your group real quick? Oh, she wouldn't.
Only since like the amount is used at 16 or something. So that's 16 to 2020.
Good,
so
good.
4 years.
Good, good. You see it? You gotta look up here. In 2016, you started, you bought it. We're seeing the estimated population. Actually, the population count was at 2016. We want to see at 2020, so we're going to put a 4 there. Okay. So it's just asking what's the amount of time. Decay, acid. You can leave it there. All right, let's go and work this out. This is where we have some calculator work, because looking at this, what are we going to do first? Multiply, or are we going to do the exponent? Exponent, PEMDAS, right? Parentheses, nothing to do in the parentheses. Exponent is next to the 4th power. This is how you'll probably enter it. You'll probably do it as 1.024. You'll enter that. You'll either hit this button if you have a Texas Instrument, TI. It's on the left side, halfway down. Or if you have a Casio or another calculator, if you're using the tiny one there, has this button. It's like an X to the Y. So you're going to push one of these, and then you're going to push 4. So let's do the calculator work. If you're not sure how to do it, you can use your phone just to have some practice. You'll need to do some calculating. So get out your phone if you don't have a calculator. So, Genevieve, do you have a phone that works? Okay, so you multiply it out. Wow, good job. can do it by hand if you want. Anybody not sure with their calculator? Okay, everyone good? You need some help on that one? Okay. So there's so many different brands. They do things different. I think that it's going to be... Oh, that's it. So we raise that one to the floor. Ooh, that's not right. How did they switch? Okay, let me try a couple of things. This 1.024. Hey, 1.024. That button. There it is. Why don't you try it on your own again? So think a button. Push the button. Okay, are we pretty confident we could find this? Honestly, the calculator work might be the trickiest part to it. We get y is equal to 35,000 times 1.029. Here's what I want you to do. I want you to calculate it so you have this long decimal. I want you to keep that stored in the calculator. Once you start, what it's going to do, you don't have to push store or anything like that. Once you find this value, all you need to do is not enter it again, just say multiply by the 35,000. Because it retains the answer to what you compute, it retains it for the next problem if you just add it to the next step. So, let's see, how much is this thing going to be worth? Let me see. I can't see from... See how so that's going to be 38. Oh yeah, because he increases. 38,000. 384.
Yeah.
3842.
No, multiply 1.024 by 4. I mean, multiply, so 1.024,
It's actually this. I want you to tell me why.
and you multiply 35,000.
Why is it that we round down? What's the topic? You can't have partial of a person, right? If it was 3 right here instead of 2, that would mean that we had a little bit more time than we did. Maybe even a few days. Maybe in a month. Thumbs up, sideways down for doing growth problems. Awesome, awesome, awesome. Okay, we are going to then move on to this problem. And I'll let you finish up the notes here if you're doing that. So we got to also put a type of units. This is 38,482 what? People? It's okay. It's okay. It's okay. All right, we're going to go right here. It's all right. Don't worry about it. Oh, sorry. All right, so we have this right here of a decay problem. Okay? And that doesn't help. That don't matter. Okay, so here we have this decay problem. Let's read it out. Let's see what we can do with it. Your new scooter, okay? In 2016 decreases in value 15% each year. The original price is $10,000. What is the value in 2021? It's like a Vespa or something like that, I guess. At first I put car and then I was like, what car costs 10 grand? A Fiat with like no wheels? I don't know. Growth or decay, guys?
Decay.
How do you know?
Decrease.
Decreases. You look for the word. Decay. What is your growth decay factor? We know that we're looking for the decay, the growth decay rate. What is the decay rate? What is that multiplier? Let's see, I have 15%. I got to do my steps. I got to move this into decimal form. It's decay, so it's 1 minus whatever that is. Whatever that is. Good. Okay, Genevieve, what is 15% in decimal?
Percent is 0.15.
Good. So I'm going to just go ahead and put that right in there. So go ahead and finish that out. What is our growth, or excuse me, our decay rate is going to be? Oh, right. There's that. 0.85. Perfect. Thank you. Okay. So essentially, if we look over here in our exponential decay problem, we already know the initial amount, right? We just figured out our whole decay rate. We can figure out the amount of time, compute it, do some calculator work, answer, check your units, done. So what is the equation for this? Let's see. Y is equal to what? Tell your neighbor, what is it? Y is equal to, what's going to go right here? Good. I see a lot of good communication. You guys are catching on with that. That's great. Let's see. Okay. Yes. Quinn, help me out. What is going to go first? Looking at our equation over there. Good, perfect. Our initial amount goes first. Let's see. Loretta, help me out with this one. How many years? I want you to help me with the exponent that's going to go here. How many years are we talking about? So first, if we're looking for years, I look to see if there's any years information in here. So I know I see 2 years here. Here's the start. Here's where we're done counting. So how many years do we have there?
Is that 2021?
Yeah, 2021. So 2016 to 2021. It's just 5 years. Okay. If I didn't know that, I could subtract them real quick. And then we already figured out the decay rate. And now's your chance. Calculator work one more time. See if you could do that. We'll finish this up. We'll be done very soon. Jackie. So when I bring it to the fifth power there, I'm not even going to round it. I'm going to get this answer in my calculator and right away just push times 10,000. So midway in the problem, keep as many decimal places, or at the calculator, all the decimal places. The final answer, I want it to the 100th place. Because we're talking about money, so I can keep it just like money, 0.01. Okay, let's go ahead and finish this up. Okay. So y is equal to 10,000 times what? Nate, help me out. What's 0.85 to the fifth power?
Oh. 4. Decimal. I don't have the decimal. I just have the answer.
You didn't keep the answer. No problem. No problem. No problem. Give me approximately. Who has a decimal? Jackie. Okay. ... Because you're going to keep all those decimal places. And then, so Nate, if you just found the answer, go ahead and help me out with that then.
4,000, sorry. 437.
Is there any sense to that?
5.
5 cents?
5 cents.
Why was it here that I kept the decimal place?
Because you don't go like 4 decimal places over 5 cents. Right?
Good. Good. And it's an amount. It's a cost.
Yeah.
So we aren't going to say 5 cents doesn't matter. Maybe I'm trying to figure that one out. Thumbs up, sideways down for decay. Can we do these all day long, easy? You won't have to do that. You'll have to do a few problems. It is on Edmodo. It is Edmodo 1 through 16. But I'll tell you, the first 4 problems, or actually 6 problems, are converting your decimal, deciding if it's growth or decay, easy answers, or find your growth rate. So about half of them are like that. And we aren't going to go further, I think, with our topics. So It's a little bit more than usual. We'll have time tomorrow to look at it. Should we tell people to subscribe? What should we do? Does anyone have anything else they want to say? Any shout outs? Anyone's mom's birthday or something? Nothing? There's nothing shout out worthy? Say what? Special? Oh, okay. You want to do a shout out for your Insta? Okay. That's fine. I'll just say subscribe. 250 gets a Kit Kat. Boom.